Boat is traveling north at 5 meters per second across a river which is flowing west at 3 meters per second, and we want to know the resulting velocity as viewed from the shore. So the boat is pointed north. The boat starts off by pointing himself in the direction straight across. Let's assume north is up. We call that the velocity in still water. So that's the speed that the boat would go and the direction that the boat would go if there was no current whatsoever. 5.0 meters per second straight up. However, there is a velocity of the river which is pointed towards the west. So let's take west as being left, and this velocity, VR, for velocity of the river, is 3 meters per second. Now, if you imagine the river as a conveyor belt, it's going to be pulling that boat from going straight north, shearing it sideways, shearing it towards the left. And we want to know what the combined velocity is. So once again, we're taking the still water velocity, which is always in the direction that the boat points, adding to the river's velocity to get the combined velocity as viewed from the shore, which we generally call the velocity with respect to the ground. And again, vector addition, these two on the left, we have to do those tip to tail. We can't simply add those two numbers up and get 8. We have to make a diagram. So try and draw it roughly to scale. So I've got the still water velocity, which is straight up at 5. And then at the tip of this vector, we start the tail of the next vector, which is VR. And it's pointed to the left, and it's only 3 meters per second. And then my answer always points from the start of this diagram towards the finish. So my resultant starts here and points towards the finish line over here. So it'll be a vector that's at an angle like that. And we'll call that VG, the velocity with respect to the ground. Now we've got a nice right triangle there, so we can solve this with regular SOHCAHTOA or regular trig equations along with Pythagoras. Okay, using Pythagoras, we'll try and solve for the magnitude of our hypotenuse, VG. And we know that Pythagoras is a squared plus b squared equals the hypotenuse squared, VG squared. And with some simple math, taking a square root, I get the magnitude of VG to be 5.8 meters per second. But then what about the direction? So I want to get a direction in here. Try and use your original numbers. Don't use the pink VG because you may have messed up the calculation. So let's use the 3 and the 5. Well, the 3 is opposite to the angle and the 5 is adjacent, so we can use tangent. Tan theta is opposite over adjacent. And then to solve for the angle, we do inverse tan. Tan inverse of 3 over 5. And if you're in degree mode, you get 31 degrees. And you can see the direction. It's swinging to the west from the north line. So it's 31 degrees west of north. So my overall answer is 5.8 meters per second at 31 degrees west of north.